In this lecture, I will explain you how to take the readings using a screw gauge. With the help of screw gauge, you can determine the thickness of a thin wire, or if you are given a glass plate, you can determine the thickness of the glass plate. Now, first let me show you the diagram of a screw gauge and explain the various parts in it. As you see here, these are the main parts of screw gauge. This part is called anvil. This is called spindle, and this is called sleeve, on which you can see a scale called pitch scale. Now this is thimble, on which you will find the head scale. This is called ratchet, locking nut, and frame. These are the main parts of a screw gauge. Now let me show you how to estimate the zero error of a screw gauge. Initially, you need to turn this ratchet until the spindle will touch the anvil. Once the spindle touches the anvil, a close look at the scale will be like this. This horizontal line is called index line. This is head scale. Head scale 0 may not coincide with the index line. Then we say there is zero error for this instrument. Now, when to take the error positive and negative? So, to estimate a zero error, a close look at the scale, say for example, the head scale 0, if it coincides with the index line, we say there is no zero error. If the head scale 0 is below the index line, we say the error is positive. Error is positive, correction is negative. Another case, it may happen that the head scale 0 may be above the index line. Then the error is taken as negative or the correction is positive. So, let us look at our case. Now, in this example, this is the index line and the 0, head scale 0 is above the index line. So, error is taken as a negative, correction is taken as positive. And we have to check how many divisions the head scale 0 is above the index line. So if this is the index line, our head scale 0 is 2 divisions above the index line. So I take the error, the 0 error, as -2, correction +2. Now let us calculate the least count of the instrument. This is the formula for the least count. Least count is equal to pitch of the screw by number of head scale divisions. But how to calculate the pitch of the screw? This is the formula for that. Distance moved by number of rotations on the head scale. So first let us determine the pitch of the screw and then thereby calculate the least count of this screw gauge. Now, if I make 5 rotations, 1, 2, 3, 4, 5. If I make 5 rotations, catching hold of the ratchet, the distance moved on the pitch scale is 5 mm. So the pitch of the screw can now be expressed as distance moved by number of rotations on the head scale. So distance moved is 5 mm by number of rotations made on the head scale is 5. So the pitch of the screw in this case is 1 mm. Now let us substitute the pitch of the screw and calculate the least count. Pitch of the screw is 1 mm by number of head scale divisions. A close look will reveal that there are 100 divisions on the head scale. As you read here 90, there are 100 divisions on the head scale. So I can express the number of head scale divisions as 100 and express the least count as 0.01 mm. This is how you estimate the least count of the screw gauge. Now let us try to measure the thickness of a lead shot, or you can also measure the thickness of any wire given to you. Now this is how you do it. The procedure is as shown. Let us put the lead shot and try to rotate this ratchet until the spindle touches the object. Once the spindle touches the object, a close look at the scales will show you that on the pitch scale, the clearly visible reading, as you read here, is 5. So this is going to be our pitch scale reading. 5 is our pitch scale reading. Similarly, the index line is coinciding with 76th division of the head scale. So I take head scale coincidence as 76. So pitch scale reading is 5 mm. Head scale coincidence is 76. Let us substitute these readings in the table. Now we are going for the first reading. So PSR stands for pitch scale reading. As you just saw, the pitch scale reading is 5. So let me write 5 mm and then head scale coincidence. Let us check the head scale coincidence. As you read here, it is 76. Let me write in the table 76. Then I apply correction to that. 76 plus 2, 78. Now 78 into least count, 0.01 mm. So this is 0.78 mm, which I am calling it as Y. So PSR is X. Corrected head scale coincidence into least count is Y. X plus Y will give us the total reading, which is 5.78 mm. Similarly, we can move the ratchet back and again try to place it in such a way the spindle will meet the object, and again go for the next reading. Pitch scale reading may be the same, but there may be a small change in the head scale coincidence. So if we are considering a thin wire in between the anvil and the spindle, at various positions, if you can determine and note down the readings, then taking the average of all these readings will give you the average thickness of the wire. In such a way, we can determine the thickness of a wire or the thickness of any glass plate using a screw gauge. Thank you.